Okay, so non-calculator, sorry, calculator power. Very first thing, I can't stress enough, get to know your calculator. Okay, if you're using a phone, that's fine for now. But when you go into the exam, you might find, well, this calculator I'm using is a wee bit different, and you're not happy. Okay, so first I would just sort out what calculator you're going to use. Okay, get used to your calculator. There's also little tricks that will make your life easier. Um, so yeah, I would do that. The biggest mistake that people also make is when they have a calculator, it's not set up right. So again, if you use a new calculator, someone gives you one on the day, the biggest mistake is for it to be set to radians, not degrees. Okay, so look for degrees in your calculator. Okay, otherwise when you come through sine and cos, you're going to get some funny answers. All right. So question one, I've just highlighted some of the important bits of information here. And again, like I was saying in another video, feel free to pause these once we chat through the question, see if you can do it, and then play, see what you're thinking. That's totally fine. So yeah, 80,000 packages in 2018. We're going to get 15% more each year. Calculate how many packages the charity expects in 2021. Okay. So again, the way I would kind of think about starting this would just be to say, well, okay, 2018, I know I've got 80,000, and I'm trying to get to 2021. Okay, just to get my brain going, I think, let's just write down the information I know. So I don't need to go 1, 2, 3 years. Okay, so yeah, that's kind of that's the question. That'd be the answer in there. Right. So that's this information used up. The only bit we've not used now is the 15%. So how do we increase something by 15%? Okay. Well, if we increase something by, let's say we were to increase something by, nothing. If it stays the same, we're going to times something by 1. Right? Times it by 1 is going to stay the same. Anything bigger than 1, we're going to increase the number. Yeah. 1 point anything is going to make this bigger. And anything less than 1 will make it smaller. So that should kind of cue your mind to think, well, it's going to be 1 point something, isn't it? Again, a big mistake is people would write, okay, I've times it by 15. Okay. Well, no, that's going to times it by 15. You're going to end up with 15 of that number. Okay. When actually, we just want 15% of the number. Okay. So we're going to times it by 1.15. Okay, that's the important bit, 1.15. Okay. If it was going down by 15% each year, we times it by 0.85 because we're taking off 15%. Okay, but this will mean we're going to increase it by 15% each year. Now you could work this out in this order. You could work that number out. What does that give us? 82,000 or 80,000 times 1.15. So that gives us 92,000. Okay, and then we could take the 92,000 and we could do the same again. Okay, times that by 1.15. Okay, we could do that. Now, the problem with that is if you get a question where it's not a few years, this method kind of breaks down. Okay, because you can't sit for ages. If it was 100 years later, we'd really struggle, wouldn't we? So, what I would say is that yep, you could do it that way, but to maybe make it quicker, we'll use our compound interest method. Okay. Now, again, if you think about what we're doing there, we're taking this number and times it by 1.15 to get a number, then times it by 1.15, times it by 1.15, and that gives a final answer. So what you're kind of doing is times it by 1.15 3 times. Okay, that's effectively what you're doing. You're not timesing it by 1.15 and times it by 3, but you're timesing it by 1.15 3 times. Okay, so the other way to write that would be to put in a bracket and give it a cube sign. Okay, that is going to give us the 2021 answer. Okay, so you could, if you wanted, if you sometimes forget this, you could just work out each year. Yeah, you could do that. That's absolutely fine. But it's probably better to try and remember this method. Okay, there's not a lot to it really. The only thing we're trying to do is remember this bit in here. So it's the number of years, and this is a percentage increase or decrease. Okay, this is a standard kind of compound interest question. Okay, now that's going to give us 121,670. Okay, and I maybe just write packages as well, although I don't think there's a mark for that. Okay, right. So if you were doing the marking, you would get a mark for your 1.15. You would get a mark for when it needs to be times to the power of 3, or times it 3 times, and then we're working it out. Okay, so for 3 marks, it's actually a very, very straightforward question. Okay, good stuff. Vectors, magnitude of vector. Again, this is a brilliant question, especially in a calculator paper. In their own calculator, they might mix it up and make you do something a little bit fancy. But for this, we can just plug this straight into a calculator. Now, people don't often think about what the magnitude really means. So this is the same for if it was a 2, an x and y vector as well. Okay, if you imagine an x and y vector, let's just say we've got 3 and 4. Okay, so we're going along 3, and we're going up 4. Okay, and we're saying what's the magnitude? Now the magnitude I always think on is this line here. Okay, and if you remember your Pythagoras, that is going to be 3 squared plus 4 squared square root. Okay, which in this case is going to give us 5. All right, but it's just standard Pythagoras, isn't it? We square this, and then we square root them. So whenever you see the magnitude, always just try and think on that that kind of Pythagoras method. Okay. So for this one, we're going to do, just make sure we write our working out nice and neat. It's obviously not an x and y, it's an x, y, z. Okay, but it's the exact same process, just squaring them and square rooting them. So the magnitude of p is going to be equal to 6 squared plus 27 squared plus minus 18 squared. And that's all going to be square rooted. Okay? Now the only tricky bit here is the minus 18. Now again, I've got a calculator. If you put this properly in your calculator, you shouldn't have any troubles. Okay? This will come out as a positive number. Okay? I'll just do them individually. Just when I was a 6 is obviously going to give us 36. 27, I'm not quite sure, that's 729. Yeah. And then the 18 squared, this is the mistake people would make. That's going to give you 324. So some people in here are going to put negative 324, but obviously it's not. Okay, and that's all square rooted as well. Okay, so if we add them together, we're going to get 324 plus 729 plus 36. So that's 797. So we've got root of 797. And this is when in a non-calculator paper they might make you do things, but obviously it's a calculator paper, so that's fine. Root 797 is going to give us, well, I've made a mistake somewhere, I think. Let me check. Okay, so sorry, that's 1089. Don't know what I've done there. 1089. Made a mistake with the calculator. And root 1089 is going to give us 33. Okay, so yeah, that's the only real place you make a mistake. Try and remember the Pythagoras kind of, what is the magnitude? Don't get caught up on the language. Just think logically about it. Okay, this is 3, this is 4, this is going to be 5. Basically it's just Pythagoras that we're doing. Okay, and then yeah, when I got to here, I had a quick look and thought, oh, this number doesn't look quite right. Double checked it. Okay, and yeah, 33. Good stuff. Oh, sorry, and I forgot to add for the marking scheme. You're getting obviously a mark for your final answer there. But the other mark lies actually just with this line. Okay, because it's a calculator paper, you don't really need to show these 2 lines. Okay, if you write this, you're getting 1 mark. But then if you put it wrong in your calculator, you're going to lose a mark, obviously. So you might want to do this extra working. But this is where the first mark is, and this is where the second mark is.